This is page 71. This whole paper is kind of trimmed up, and we will put these 4 examples on page 71 in our notes. We'll kind of have to put it in sideways. This is geometry 4, which is working on surface area, so we want to make sure you write that in and box that in for your notes. So a couple things we need to do. We're going to practice these 4 examples, and that's how we're going to practice surface area. Surface area is finding the area of all surfaces, and you're just adding them all together. So in this particular one, we're supposed to draw and label a net, and then find the area of each face, and then find the total surface area. So a couple ways I like to do this. First off, this is a rectangular prism. We need to know how shapes are named, and prisms mean that they have rectangles on their sides, and they're also labeled by their bases for this. And so I like to kind of organize my thoughts here. I like to draw the net of this shape, and I will show you that as well because I have the nets that you can go actually grab and touch and use. But the net of this particular shape is going to look like this. We've got rectangles here in the middle, so we're going to make it have 1, 2, 3, and 4 rectangles in the middle, and then this on this side, and then this one on the side, which is the same thing as the net looks like that I'm showing you here in class. And so what you have to do is you have to find the area of each one of these faces. I also like to use the 3D figure. I think that helps me to organize. So when I look at this figure, I can break it down into left and right, and then I can break it down into top and bottom, and then I can break it down into, let's see, left, right, top, bottom, so then I would have front and back. And the reason why I do that is if I find the area of the left side, then I actually know the area of the right side. So the left side, kind of shaded in so you can see. This is the left side. This is what I'm talking about over here. As I'm kind of tracing going around the edges, you can see in order to get the area of this rectangle over here, I would have to take length times width. That would be my 2 and my 4. So for the left side, I've got to take 4 times 2, which equals 8. And if 8's for the left, and I could double it because I know the right side's also 8, then I know my left and right together is 16, let's call it inches squared, because that's what they're labeling. So then I would look at maybe the top and the bottom, and maybe the top's easier, so I'm going to kind of do this for the top. Put little diagonals here going back, and maybe just kind of trace the top. What dimensions do you see as I go across the front, this side, across the back? And if you have to do it again so that you can see the dimensions, looks like 11 going across, and then what's this dimension here? 2. 11 and 2. So to find the area of this top rectangle, I need to take 2 times 11, which is 22. And since I know the top's 22, the bottom's also, so I can double it. Top and bottom are both 22, so then together that would be 44 inches squared. And then the last one I need to find is the front and the back. And I don't know if it's easy to trace the front, and you can see the front going across here. What dimension is the going across here? That's our 11, then going up. I don't see it here, but as I'm tracing it, oh, up and down is the 4. So 4 and 11. So I need to take 4 times 11, which is 44 for the front. And then if I double it, then the back's also 44. So then I would have 88 inches squared for the back. And so then if I just add these numbers together, that's my total surface area. Left, right, top, bottom, front, back. So if I add 16 plus 44 plus 88, and my calculator says 148, and that would be inches squared for the total surface area. So I want to fill that in up here, 148 inches squared for the total surface area. So you kind of break it up. Some people start to notice that you got to take 4 times 2 and double it, 2 times 11 and double it, and then 11 times 4 and double it. As long as you take each set of numbers times each other and then double it, you will have all of the areas. Another way to look at it is when we initially found the left, that was worth 8, and the right was worth 8. When we did the top and the bottom, 2 times 11, one was 22, and the other one's 22. When I'm writing these in here on the net, they're never right next to each other because top and bottom are like opposite sides, so you kind of have to space them out. And then when I did front and back, each one was 44. And so that's what it looks like finding the area of each dimension on the net, and then you could add all those together. So I want to move this up so that you can see the next one here. The next one, we need to find the surface area of this shape. It's triangular. It's not a pyramid. Pyramids only are pyramids when they reach at one point. So this is a prism. This is actually an equilateral triangular prism. So what do we know about an equilateral triangular prism? Well, the net, I can show you the net. It's going to have rectangles for its middles. And the rectangles, there are 3 of them, and then there's a triangle on this side, and then there's a triangle on this side. So that's what this net looks like if I were to open this up. And so again, I just like you to find the area of each side and then add those together. So if I trace this top here where all of the dimensions are given here, this is a triangle. So how do I find the area of a triangle? We need to use the area of a triangle formula, which is base times height divided by 2. Well, what do we know about base and height? They make a right angle. And so of all the numbers given, 6 is our base and our height is 5.2. So you've got to fill in your blanks here with 6 times 5.2 and then divide it by 2. So that's your base and your height. And when I do that, I get 15.6 inches squared. And that is the area of just one triangle. So I'm going to label that area of one triangle. But remember, we have a triangle on the top. We also have a triangle on the bottom. So it's like this one over here has to be 15.6, but this one over here also has to be 15.6. So since there's 2 of them, I need to take 15.6 times 2 BC because we have 2 triangles here. 15.6 times 2 gives me 31.2 inches squared, and that is the area of my 2 triangles. So I want to organize that. I have my area of my 2 triangles here. Okay, so I've got the area of both of them together. They were each 15.6. Now I need to find the area of all of my rectangles, and this is a little trickier. So if I trace my rectangles, what's the dimension of the rectangle? I see going up this side's 10, and what's this side? 6. 10 times 6 is 60 for the area of the rectangle, right? Area of a rectangle, we call that length times width. So we're going to take 6 times 10, and that is 60 inches squared. But that is only the area of one rectangle, and I actually have 3. So if I know this one's 60, this one's 60, and this one's 60, I've got to go around all the sides. And so you could take it times 3 because there are 3 rectangles. Then 180 inches squared would equal all 3 rectangles for their area. So I've got the 180 for my rectangles, and I have the 31.2 for my 2 triangles. So then I have to add those as my final. So I need to add my 31.2 plus my 180 for a grand total of 211.2 inches squared for the entire surface area. And you could fill that in up here, 211.2 inches squared. So I think it's really important to a surface area is that you're organizing your notes and you're organizing your thoughts. Once you get the area of the shapes, you kind of write that down. Okay, moving on, we're going to go over to this example over here. So with this example, we have a cube has an edge of 7.5 centimeters. Draw and label the cube, the net, find its surface area. So first off, I'm just going to help you draw a cube. A cube, if you were to draw it 3D, you would draw a square, or your best to draw a square. Then you put a dot in the middle, and then you go down. You're going to go over and over like that. So you have your 2 squares. And so then you're just ready to connect this dot back. So all of the backs are at the same diagonal. Your pen goes forward to back, all 4 times to draw that. They're saying it has an edge of 7.5 centimeters, which means this is 7.5 centimeters here, this is 7.5 centimeters here, this is 7.5 centimeters here. Each side length has 7.5. Why do we know that? What do we know about a cube? All sides are the same. To draw a net, I can show you that. In the net, you've got perfect squares here. So when you're drawing this, trying to make them look like perfect squares. And then coming down, a cube has 6 sides, so you got to make sure you have your 6 boxes. 1, 2, 3, 4, 5, one more, 6, and they're all supposed to be perfect squares, so that's what you're trying to draw, is to make them look like they're all perfect. And so how do you find the surface area of all of these? We've actually done this formula a lot of times and it confused a lot of you. Couldn't you just find the area of one square? Well, if you know this is 7.5 and this is 7.5, you could multiply them together to get the area of one square. Once you get the area of one square, then you could times it by 6 since there are 6 squares there. So 7.5 times 7.5 gives me 56.25. We could call this centimeters squared. And we want to organize our thoughts. That is the area of one square. But we want to take it times 6 because there are 6 total squares here on our calculator. When I take that times 6, I get 337.50 centimeters squared. And so some people will try to take all these times each other, but you don't. You just find the area of one square. Once you find one, you take it times 6 to get the total surface area of the cube. And you could fill that in here on this line. For your cube. The last one is actually a pyramid. They all reach at a point. We name the pyramids by their bases. So you would have to look at the base. As you look at its dimensions, 15 by 15 is a perfect square. So this is a square pyramid. It all reaches to a point. So we're going to draw its net. I'm going to draw it here because I've got some space right here. You have a square in the middle. And then coming off of the square are triangles from every direction. One going this way, one coming this way, one coming this way, and then one that way. So you could find the area of the square and then the area of all 4 triangles and add them together. So how do I find the area of the one square? I trace it. I see 15 on one side and 15 on the other. So 15 times 15 gives me 225 centimeters squared, and that gives us the area of the one square. So we've got one part done. Now we need to find the area of the triangles. So I try to find the one that has the dimensions given to us. It looks like the one on the right is kind of given to us, so I'm going to trace it. So going up and down and around. Now remember, area of the one triangle, we use our base times height and divide by 2 formula. So we've got to figure out what our base and our height is before we divide by 2. So as I'm tracing this, it looks like this dotted line coming down would be our base, and they've labeled that 20, or I'm sorry, that's our height, labeled 20, and then this would be our base, 15. So filling in 15 and 20, and then you can say 15 times 20 divided by 2 is going to give us 150 centimeters squared. Now that's for one triangle, but we need to take that times 4 because there are actually 4 triangles. So 150 times 4, the 4 triangles, the area for all of them is actually 600 centimeters squared. So if you wanted to write each one in over here on the net, you could say this is 150, this one over here is 150, that's 150, 150. Even our square was 225. And then you could add all these numbers together. Or you could kind of group them like this, your 225, and then the 4 of them together is 600. So what happens when I add 225 plus 600? My grand total is 825 centimeters squared for the entire surface area, and you could fill that in on your line here. So whatever works to organize your thoughts for that. Some people will say, well, what if I didn't divide by 2? I would have found the area of 2 triangles, and then I could have doubled it to find the other 2. However it works for you to see that, to get the surface area. So the homework you're going to do for this is a worksheet, page 124, 125. It is a front and back. You are going to do the evens, and you may use a calculator. You need to show work just like we did here and organize your thoughts just like we did here.